In this video, I want to talk about Fischer projections. Our book actually doesn't include Fischer projections, but I do want to include them. If you go on and take biochemistry, you're going to see a lot of Fischer projections. So straight chain monosaccharides, carbohydrates are generally written as Fischer projections. Sometimes you'll see amino acids written that way also. So I do want you to become familiar with them. Even if you're not going on and taking biochemistry, I honestly think determining RNS configuration is easier when something is in a Fischer projection. So what we're doing with the Fischer projection is we're drawing something in 2 dimensions, but we're assuming 3 dimensions. So what we're doing is we're going to draw an intersection of lines like this. Where it intersects, this is going to be my chiral center. There's a few exceptions where you might have a couple chiral centers and one in the middle isn't chiral, but in general, where your 2 lines intersect is going to be your chiral center. And then you're drawing it flat like that, but it is assumed that, and I'm going to erase that line here in a minute, that the ones that are coming out at you, the horizontal lines are coming out at you. So you don't draw them wedged when we draw a Fischer. We draw them planar, just like I did above, but we need to remember that those horizontal ones are coming out at you. And then the vertical ones are actually going back. Right? We didn't all of a sudden morph into 90-degree bond angles. It's still tetrahedral. It's just that this is the orientation. So we draw it like this, right? So drawn like this, but assumed to be like this. So what we're doing is we're taking our tetrahedral molecule and we're kind of tipping it back. So I'm going to show you a model here of what that looks like. So I have our tetrahedral molecule drawn kind of normally how I would draw it, right? We have 2 in the plane. So I use my paper here, right? These 2 are in the plane, and then the green one's coming out and my orange one is going back. And what we're going to do is we're going to actually just take it and we're going to flip it like this. So these are the ones that are vertical, right? They're going back at you. Get it straight here. And these ones are my horizontal ones that are coming out. So if we were to look at the plane now, right? The one where my hand is, right? The green one and the purple one are coming out at you. And then if we look behind that plane, right? I have my white one and my orange one. So even though we're drawing it planar, we do need to remember that it's not flat, right? It's not planar. I don't have 90-degree bond angles. It's still tetrahedral. It's still 109.5. We're just taking it from this position and we're tilting it back into this position. So always, always, always when something's in a Fischer projection, the ones on the top and the bottom are going back at you. The ones at the side are coming out at you. So let's draw a molecule. I'm just going to draw it how I normally would if I was to draw it tetrahedral, and then we'll put it into a Fischer projection. So I'll do a hydrogen, methyl group, hydroxyl group, and let's do a fluorine. So right now, right, the fluorine, the bond to the fluorine and the bond to that hydroxyl group are in the plane of your paper, my iPad, screen, however you want to think about it, right? The hydrogen's coming out and then the methyl group is going back. So kind of how I think of putting this into a Fischer is I'm going to actually take these groups and I'm going to rotate them. I'm going to take the whole thing and I'm going to kind of tilt it, rotate it to the left. So when I do that, what's going to happen is this hydrogen is actually going to like swing over here, right? I'm tipping it in that direction. So that hydrogen is going to be in this position. My methyl group is going to be in this position. And keep in mind, those are both coming out at us. We're just drawing it planar, right? We just took the whole thing and tilted it. And then this fluorine is going back, and then this hydroxyl group is also going back. The easiest way for me to draw these is to keep the 2 that are in the plane, right, those ones, and make those the top and the bottom. And then because I need to get these groups, right? These groups in a fissure need to be coming out at us. I need to tilt it, right? Swing it in this direction. If I was to take it and swing it in the opposite direction, right? If I was to swing it this way, then what's going to happen is that hydrogen and that methyl group are going to be going back. And in a fissure, right, it has to be coming forward. If you were to draw these groups going back, which is what would happen if you would tilt, swing it around in that direction, it wouldn't be a Fischer projection. So the only way to get those groups coming out, right, is to swing it in this direction. To figure out priority or figure out my configuration now, my lowest priority group is always going to be going out or going back. If it's going back, we just do 1 to 2 to 3, right? If it's clockwise, it's R. If it's counterclockwise, it's S. If my lowest priority group is coming out at me, then I'm going to do the 1 to 2 to 3, right? Same thing. Clockwise is R, counterclockwise is S, but then I'm going to switch my answer because it's coming out instead of going back. Being in the plane isn't an option, right? If I look at my fissure here, there isn't a bond that's in the plane. So once I put it in a fissure, I can just either take the answer as it is if my lowest priority group is on the top or the bottom, right? If my lowest priority group is in this position or this position, it's going back. If my lowest priority group is in one of the horizontal positions, now it's coming out instead of going back, and I'm going to switch my answer. So once you get into a fissure, you're not going to have to redraw it, right? You don't have to twist it. You don't have to do anything. And it's easier for me to actually take this and put it in a fissure oftentimes than it is to try to rotate it and then bend it back or look at it from behind. So I put it in a fissure and then figure out the configuration is how I tend to do these. So I'm going to assign priority. So fluorine's actually my highest priority group this time. Oxygen, my methyl group, and then hydrogen's my lowest priority group. I'm just going to leave the 4 off. As I go from 1 to 2 to 3, I am going in the clockwise direction, which is R, but my lowest priority group is coming forward. So I need to reverse my answer. So this is going to be an S configuration. And we could double check it. This one, because I have the lowest priority group coming out, it's not really all that hard to do. So we could do 1, 2. When I say it's not that hard, it's still kind of hard. It's just relative to what it could be, right? I could make it worse. I'm going to go from 1 to 2 to 3. I'm going in that direction. That direction is clockwise. But again, my lowest priority group is coming out. So we do need to switch our answer to S. So let's do another one. And we'll have a hydroxyl group here. So I am going to put this in a Fischer projection for practice. So this is my chiral center, right? I'm not showing the hydrogen, but there is a hydrogen going back. Now for me, I'm always going to put the ones that are in the plane on the top and the bottom. So I'm choosing to put, and you could flip it, either way, but I'm choosing to put the methyl group here. And then I have a CH2, CH2, CH3. I'm putting that there. You could have switched those two. You don't have to put the ones that are in the plane on the top and the bottom, but I find that if you're consistent, you're going to make less mistakes. Right? I want to draw this structure in a fissure. I don't want to draw it's an enantiomer in a fissure, right? That's not what we're asked to do. So I'm going to draw that. And then how I'm getting it there, essentially what I'm doing, this is kind of hard to explain without being able to use my hands to show you, but I'm swinging this up, right? Because that's my top. I'm swinging this down, but then I also need to tilt it so this group is back, and then this stuff is back also. So what's happening is this stuff is kind of swinging around, and my hydroxyl group is going to be over here. And we can make a model and I can kind of show you how we're doing that, but that's what I'm coming up with. Assigning priority to those groups. Hopefully you guys are getting good at these. Anytime I go to assign priority, it would be a really good idea, like as soon as I say let's assign priority, to hit pause and do it yourself. Figure out the configuration yourself and then come back, right? You can watch me do it all day long, but until you actually try it yourself, you're not going to truly learn it. So please, anytime I do this, I would like you to hit pause and give it a shot on your own. So 1 to 2 to 3, 2 is down here, 1 is here, 3 is here. So I'm going to go in this direction. That direction is counterclockwise, so S, but again, my lowest priority group is coming out at us, right? Remember that the positions, I'm back up here again, the positions that are horizontal are coming out. So I do need to reverse that answer. We should maybe write that. So if the lowest priority group is in a horizontal position, sorry, horizontal, I can spell really. You need to reverse, actually let's say it's coming forward. Right, it's coming out at you. So reverse your answer, right? As you go from 1 to 2 to 3, if it's clockwise, instead of being R, you're gonna switch it to S. If it's counterclockwise, instead of S, you're gonna switch it to R. So reverse whatever you get. Okay, so let's look at that last one and see how we put it into our Fischer projection. So I'm just scrolling down here a little bit so we can see it. So this is what we have. I have my pentane, right, my chain of 5 carbons, and then I didn't put the hydrogen on it, or any of the hydrogens on, I guess, for that matter, except for this one. But there would be hydrogens on all those carbons. The models just get really messy to see what's going on when I put all those hydrogens on, so I typically don't, which I'm sure you've noticed. So this is an oxygen, pretend the hydrogen's there, and then I have a hydrogen here. So right now I have my hydroxyl group coming out at you, and I have my hydrogen going back. So what I'm doing when I put this one to Fischer is I'm taking this, and I did put the methyl group on top, so I'm tilting it in this direction. So we're just taking it, and I'm doing this with it. So this propyl group, right, and this methyl group are both going back. I have my hydrogen, and then I also have that hydroxyl group. We can draw Fischer projections for molecules that have more than one chiral center. So if I look at this one, I'm going to put a bromine on here and then a bromine here. And I'm not showing wedges and dashes, right? I'm not showing stereochemistry on this. I don't know if my bromines are coming out or going back. We'll do this example twice. Once without showing, because I just want to show you how what the Fischer projection would look like, kind of the outline without the groups on it. And then I'll give it some perspective. We'll have some groups coming out or back, and then we'll kind of redo it. But to start, I just want to note that I do have 2 chiral centers, right? That carbon has this methyl group, a hydrogen, a bromine, and then the rest of this molecule, which is different than those other groups. And then I have a second chiral center. It has a bromine, a hydrogen, this ethyl group, and then the rest of the molecule, which is different than the bromine, the hydrogen, and that ethyl group. So I'm going to have 2 chiral centers. So when I draw my Fischer for this, I'm going to have it like that, where each one of those is going to be one of those chiral centers. Before I actually put perspective on that, let me do one more. So I have a bromine. We need to make this longer, otherwise it's not chiral. And then a bromine here. So 2 chiral centers again. The problem is in between those 2 chiral centers, I do have a carbon. So when I'm drawing this one, I can't just ignore that carbon exists. I do have to include it. So this middle carbon would have 2 hydrogens on it. So that's not a chiral center, but it does have those 2 hydrogen on it, and we can't ignore that carbon, so we do have to include it. So when I first introduced, right, Fischer projections, I said in general or usually, right, the intersection is a chiral center, and so there was some exceptions. This is kind of that exception. I can't just leave a carbon off of my projection, and it's between the 2 chiral centers, so I do have to show it there. It's just I would put 2 hydrogens on it. And then all of these, when I put it in the projection, this one and the one up above, even though we're drawing it flat, remember, these groups are coming out at us, right? These are all going to be wedged. That's the most horrible wedge ever. But those are all going to be wedged, right, on all of these. All of your horizontal positions are always going to be coming out at you. And then these vertical ones are going back. The ones in the middle are actually in the plane. So always horizontal coming out. And then the top and the bottom in this case, right, my vertical, are going back. So when we do take this and put it in a Fischer, as always, we need to make sure that we tilt it in that direction, right? We don't want to tilt it in the opposite direction. So I'm going to redraw this one, but I'm going to give it some perspective. I'm going to put wedges and dashes on those bromines and hydrogens, and we're going to draw in its Fischer projection. So let's have this bromine coming out and my hydrogen going back, and then let's do it the opposite on this one. Bromine back and hydrogen out. Okay. So again, if I have stereochemistry and I don't want to mess it up, like if I go back to this one, because I'm not showing stereochemistry, it doesn't matter where I put any of those groups as long as this chiral center here has the things that are attached to that chiral center. So one of those positions would have a methyl group, one would have a hydrogen, and one would have a bromine. And it doesn't matter where I put any of those 3. As long as those 3 things are on that carbon, I'm fine, because I'm not showing stereochemistry. As soon as I show wedges and dashes, now it matters, because we don't want to draw something that's oriented in 3 dimensions differently than the thing that I'm giving you, right? If I'm giving you a specific orientation, you need to draw that specific orientation. If I don't give you an orientation like this one, then just whatever, right? I'm not specifying, but now I'm specifying. So if I'm given something like this, I still like to put the ones that are in the plane on the top and the bottom. So I'm going to put this methyl group here and then a CH2, CH3. Again, I'm kind of a creature of habit when it comes to this. It's just easier for me if I can do it the same way. Sometimes you can't, but this one I can. What makes this problem slightly more complicated is that I actually have to rotate this bond right here. Because if I don't, notice that this is coming up and I need it to be going back, right? If I was to take this whole thing and kind of rotate it, so this is up and this is down, and then tilt it, what's going to happen is these 2 groups are going to be coming out at me, but these 2 groups are going to be going back. And that's not what I want, right? I need all of my horizontal positions to be coming out. So what I'm going to have to do is, right now this is in a staggered conformation. I'm going to have to rotate it so it's eclipsed. And again, we don't want to change the stereochemistry. I just want to rotate it. So I'm going to take this bond, not erase it. I'm going to take this bond and I'm going to rotate it in this direction. You can rotate it in any direction you want, but again, I'm a creature of habit. I tend to rotate things the same every time. So I didn't change that first carbon. I'm keeping that one the same. And then rotating that bond between my 2 chiral centers, I'm rotating it so that's going back. And then that one up, down, it doesn't matter. And then what's happening, that bromine that's going back, as I rotate that around, it's going to pop out at us. That hydrogen that's coming out, as I rotate it around, it's going to go to the back. So now when I take this and put this in my Fischer projection, right, I'm taking this part and I'm going up with it. I'm taking this part and I'm going down with it. And then I'm also kind of tilting it so both of these groups are coming out. When I do that, my bromines are going to come over to the left-hand side, both of them, right, because they're both coming out right now. And then my hydrogens are going to be on the right. So bromines on the left, hydrogens on the right when I tilt that back. If you do have a model kit, it would probably be good to play with this. If you don't, you can actually just take a couple pencils and hold them, so like have two of them, one representing the hydrogen, one representing the bromine, and then just kind of twist them around and see what happens. I didn't have a model kit when I was in college, and you can do a lot with a handful of pencils and pens. So if you can get them oriented correctly and then move them without losing their orientation, that also works.